What you get back is a total mirror of the circuit that you've designed, which won't work at all. So you have to be careful of things like that. And the easy way to double check that is you can print a report of your file, I believe. If you go to the print part of it, I think it's actually, you can export a report somewhere, can't you, John? If I remember right. Yes, there's a assembly, you can print the assembly one, and it will actually show you a picture of what your board's going to end up looking like. And then you can just double check it before it goes off to the manufacturer. But when it goes, we are sending the boards to PCB and I'm just going to give you a quick example of their expectations. Every board manufacturer has what's called their capabilities. And you can normally find that on the website, and up here, we can see it up here, capabilities. If we have a quick look at that, this is showing you what their manufacture process is capable of producing for you. So if you want something that desires a greater capability than they offer, they can't do your board for you. Just as an example, I can show you a few here. PCB can do up to a 10-layer board. Well, we're on 2 layers. They can do FR4 aluminiums. These are the substrates they can do. Down here as well, somewhere you'll have a min trace and a min spacing. So their min trace and spacing is 4 mil, 4 thou by 4 thou. So if you did not check and you gave them a 2 thou by 2 thou, you would get no board back because the copper would just dissolve off of it.
But they would still make it, that's an important point.
Yeah, because they'll still charge you for it.
They'll still charge you for it, you'll get a board back with the tracks missing, but the responsibility lays with the person that's designed the board, not with the person that manufactured it. They'll just do it blindly, they won't even look at it.
Yep.
So just come off the production and go into an envelope and be posted back with it.
The other thing that's worth noting is drill size. So if you put a hole down or a little drill or something like that, you need to make sure that it's the minimum they can do is 0.2 mil, but they're pointing out here that anything smaller than 0.3 mil will be subject to extra charges because it ends up being laser shot through. So you have to be careful with things like that. So that's the capabilities. And just to give you another example of how to process this, we're going to send your boards off. We've given you a maximum constraint of 100 mil by 100 mil. You're only going to be doing 2-layer boards, a top and a bottom. So we're going to have a minimum of 5, and our thickness in this 1.6 mil is a standard FR4 thickness. You can get 1.6 mil, 1 mil, 1.2 mil, but 1.6 is the most standard, so it's going to be the cheapest. And if we hit our quote button here, now it asks you lots of information. And most of the defaults here are fine, because it's already taken across our size, our quantities and our layers. This is the substrate or the material that we're going to be used. And then we have all sorts of things like the thickness, the minimum tracing. Because we're on a 6x6, our price is low, it's only $5. If I decided, oh, you know, actually we've done a 3x3 board, look what's happened, it's gone from $5 to $120. Yeah, John's not going to be happy with you spending his budget like that, trust me. Again, with the hole size, minimums, if we go down to 0.2 hole, you see the jump across there has gone up to $64. So this is important stuff to keep in mind when you're manufacturing boards. Solder mask shouldn't make any difference. You can choose if you want a white one, it shouldn't change the price, it doesn't.
But I would add it's us that's going to control these parameters.
Yes, these are us, but you know, it's interesting to know what you need to know when you're sending a board off. So that's really what we're looking for. We're going to give you a 1.6 mil board. We're going to have a minimum of